Okay, a few quick examples for page 572 to help you with your homework. First of all, to find the cosine of 38.7 degrees, first of all, check the mode of your calculator and make sure you're in degree mode. We did that in class today, so most of you should be all set. So then just hit the cosine button and then do 38.7, and when you get your answer, I want a 4-digit answer. So the answer should be 0.7804. Look at the fifth number and see what it is. Mine was 78043, so I round that and call it 0.7804. All right, what about this one, cosecant? And you look and you don't have a cosecant button. So what you have to do is you have to do the sine of 163.8 degrees. And then once we get the answer, we'll do the reciprocal of the answer, just like we were doing in class today, because the sine and the cosecant are reciprocal functions. For example, if the sine of a number had the answer 2/3, the cosecant would be 3/2. So they are reciprocals of each other. So since they are, we do the sine because we do have a sine button on our calculator. So you type in sine 163.8. and you get an answer. Once you get an answer, you're going to use the x-1 key. And then when you type that key in, you'll find it. It's right above the x squared, right below the math button. Hit that key and it's going to give you the answer, 3.584. And again, round to 4 digits. Basically, what the x-1 key does is it takes the reciprocal of your answer for sine. And remember, sine and cosecant are reciprocals of each other. Now, a couple other tricky things. Tangent 173.20, we need to get the decimal for 0.20. Do you remember how to do that? There's 60 minutes in a degree, so go 20 divided by 60. So 20 divided by 60 is 33. So 33.3. So now what I do is I do plus 173, hit enter, and you'll get that. And then you'll do the tangent of that answer. So, so let's do that again. I'm going to do 20 divided by 60. 20 divided by 60 plus 173. So I have 173.3 repeating all the way to the end. And then I'm going to do the tangent of that. So basically I can do tangent second answer. So that way I don't have to type in the numbers again and I have a more exact answer. And that should work just fine. And the answer is negative 0.11688. So the answer is negative 0.1169. I have to round up because it was 688. So there's the answer for tangent of 173.20. Okay, this next one's a little bit tricky because they're giving me what the cosine of some theta is and they want me to find the angle. So I'm sort of going backwards from the answer for cosine to find what angle it is. Again, make sure you're in degree mode. And then this one's pretty easy. Basically, you're going to use the cosine -1 button or second cosine. So if I was doing a key code list for you, you're going to do the second button. And then you're going to press the cosine button. And then you're going to type in 0.8621. All right, and let's try that. And when you do that, you're going to get 30.4468052, and it goes on forever. Now, what happens is the question wanted degrees, minutes, and seconds. So I know this answer is 30 degrees. And then what do I do next? I take and I subtract 30 from that decimal. So subtract 30. Leaving it in your calculator. Now all you have is the decimal point, right? And we're going to take this and times it by 60. So times it by 60. And you get 20.8, which is about 26.8, which is about 27 minutes. So they wanted degrees in minutes. So there you go. Okay, in this one, they want two angles that have that for the sine. So an added complication here. This is like number 37 on 572. So not only do I have to find the sine of that, but I have to find two angles that have that exact same sine. So the first thing you do, which is the easy part, is find out what angle could this stand for. So again, you use the second button, and then the sine button, and then you're going to type in 0.4825, and when you do that, use your calculator, you're going to do that, and you're going to get 28.848, so round that to 4 digits, so 28.85. So that equals 28.85 degrees. There's an answer. Oh, but the book wanted two answers. They said find two angles. So then you have to think back. Remember we talked about where can the angles be positive and negative? And they're all positive in the first quadrant. The sine is positive in the second quadrant. The tangent and its partner function in the third, and the cosine in the fourth. So that means that this decimal answer for sine could have been in the first quadrant, and if it was, then the angle is surely 28.85. But where else could the sine be positive? In the second quadrant. So one answer is 28.85, but I need a second answer. In the second quadrant, I also have to think 28.85. And so I need to give a name for that. Do you remember how to do that? Well, all the way from 0 to there, what is that? So, well, if I go all the way to here, it's 180. So just take 180 and subtract 28.85. And what do you get? 152.15. So 152 degrees, 0.15 degrees is the answer for the other angle that is also positive in that. All right, let me do one more example here. Okay, this one's a little tricky. So first of all, where is the tangent negative? What quadrants can the tangent be negative in? Well, it's positive here and here, so my two answers are going to be in the second quadrant and the third quadrant. So now, all I need to do is get the degrees, and then I sketch it into both of those, and then find the real name coming from 0 to that angle. So the first part's kind of a no-brainer. Second, and then tangent, and then type in that number. And when you do, you get a negative 60.28. And you try that. That's degrees. So where can that angle be? Well, it can be down here, 60.28, and it can also be up here, 60.28. What are the real names for those? Well, if I was to go this way, right, what is the name for that? So basically what I want to do is I want to do 180, take away 60.28, and I get 119.72 degrees. That's the name for that angle. I also need the name for this one. Well, I'm going all the way from here, all the way around. If I go all the way to 360, I've gone too far. But I use that as to help me figure this out. So I do 360 take away 60.28. And I get 299.72. Now, even though this came out negative, when you're using it to figure out the two other angles, use it as a positive. So if I wanted the theta reference for that, it would be 60.28. Okay, theta reference is always positive. You always want to use your positive angle when you're figuring out the real name of it in the other quadrants. So there's how to do a tricky one here. Good luck on the homework.